So in the last lecture we had a problem where we have arrived at the approximate natural frequency, the fundamental frequency, using Dunkerley's method for this problem, which is 3-degree freedom system problem, where there are 3 displacement coordinates which measure the independent displacement of mass when they are connected and suspended by a system by spring stiffnesses as 3k, k and k. We also explained how to derive the influence coefficient alpha in the last lecture, and this is the influence coefficient matrix which we have derived in the last lecture, and we already know that since the displacement coordinates are measured at the same points where the mass is lumped, the mass matrix becomes diagonally dominant and off diagonal terms in this case becomes 0. Our objective is to find omega and phi. Dunkerley system or Dunkerley's method will not give me the mode shape, but I am going to derive use this method which is called as influence coefficient method to find out parallelly the pair of omega and phi, that is natural frequency and the mode shape. Mode shape is actually the physical representation of relative position of mass with respect to the other degrees of freedom when the vibrating system is excited or vibrated at a specific frequency, which is a pair of the mode shape. So we intended to write the control equations, and I already said this is an iterative scheme. So there is a specific method by which I can write this equation. So what I should do here is alpha 1 1 2 1 3 1 So these are nothing but the values of 1 1 2 1 and 3 1 as it is column wise I have written. After I do this, I simply say m1 x1 double dot and so on. We also know that xi double dot is minus omega square xi, for xi being a sinusoidal function which has been assumed. So substitute back in this equation, I get so m1, similarly m2, so the minus sign in this case will get cancelled with this negative sign. So I can remove these negative signs here, simply say omega square x1. I can transform this in a matrix format. Omega square of the alpha matrix, which is nothing but the influence coefficient matrix, that is what I will get here, multiplied by the same vector. Okay. So now we can clearly see there is an iteration scheme being set here, because I assume the left hand side of this equation, get the right hand side, and I can substitute back and compare the value what I obtained with the value what I have substituted. If they match, I say it is converged, not matching keep on iterating. So I had an iterative scheme here now. So let me do the scheme now here. So my control equation is going to be x1 x2 x3 omega square by 3k, because alpha has a constant here 3k out. So I should say omega square by 3k of So this alpha matrix slightly modified because this is not going to be the same matrix here, I am multiplying here with M1 the coefficients with M2. So I should say this will be, let us say, M1 times of alpha 1 1, M1 times of alpha 2 1 and M1 times of alpha 3 1 and so on. So all these values will be M2s, all these values will be M3s. So I will substitute back here, M1 I already know it is 4, so substitute back this multiplier value here, I get this matrix as 1 4 and 7 of x1 x2 x3. So this is my control equation 1. So we already know for the first mode shape I will have 0 crossing, all will be positive. So I assume one 2 4. You can even start with 1 1 1, you can start with 1 2 3 any number, but only thing is since we are looking for the first mode I understand them all of them should be positive, there will be no 0 crossing. So I do this and see what happens. Multiply with again 1 2 4, I get omega square by 3k. So there is a small correction here, please see this how we are doing it. So let us multiply this the first row with first column, because this is a 3 by 3 matrix and this is 3 by 1, I will ultimately get a 3 by 1 vector which I am getting here. So the first value will be 4 plus 4 8 plus 4 12. So instead of writing 12 here I am taking this 12 out, I am putting 1 here. Okay. Similarly the second will be 3. And 4. So I started with 1 2 4, but I am getting 1 3 4, it is not converged. So let us repeat it. I am going for 2 decimal convergence. The last one is wrong, I think. So it is 4, not 4.67, this is 4. So again it is not converging because 3.14, so keep on repeating and tell me what is the final value you are getting. I have to unfortunately do it on the same space of the board because I need this as well as I need this. So worst be worst I will just rub this and keep on doing this. I am not going to do that, you will tell me what is the final value after convergence. So, I will remove this and tell me what is the final value you are getting. So, keep on doing the operation again and again. So, after the fourth step of iteration, I am getting this as 1, 3.16 and 4, matching with 1, 3.16 and 4, and the multiplier is 14.32. This multiplier is 14.32. This is what I will get after the fourth iteration. So, how to get omega from this? So, I already know that 1 3.164 is same as 14.32 times of omega square 3k of 1 3.164, that is what I am getting from the iteration scheme, right. So, equate the first row. So, I can rewrite it separately. 1 is equal to 14.32 omega square by 3k of 1. I can get omega from this as root k by m. The value will be 0.457. Whereas, if we compare this with Dunkerley, it was 0.4. So, the corresponding mode shape, which I call as phi 1, is this value 1 3.16. Then remove this. So, now I will use principle of orthogonality to get the second mode. We already know the first mode. Let us say if I have first modes as A1 B1 C1, this is the first mode, and the second modes are A2 B2 C2, then according to the principle of orthogonality I should say M1 A1 A2 M2 B1 B2 plus M3 C1 C2. When I am crossing the modes, what should be this value? Should be 0. So, M1 from my problem is 4m, A1 for my problem is 1, A2 I do not know, that is the second mode, plus M2 for my problem is 2m, B1 is 3.16, B2 I do not know, M3 is simply M, C1 is 4, C2 I do not know. So I have only one equation where I have got 3 unknowns, A2, B2 and C2. So how do I get it? Okay, I will remove this. Remember, mode shapes are relative displacements of the mass position when the system is vibrating at a specific frequency, in this case let us say for example omega 2. So what I do is let C2 be called as C2 and B2 be called as B2, let us remain as C2 and B2. I find A2 in terms of C2 and B2, that can be easily found. Okay. So from this expression, so what is that you get for A2? So minus 1.58 B2 minus C2, that is what you will get when you solve this. I write this in a matrix form. So I say that A2 B2 C2, which is my second mode, is nothing but so you can read it, A2 will be equal to minus 1.58 B2 minus 1 C2, that is what I am getting here. B2 is nothing but B2 and C2 is nothing but C2. So all these equations are transformed in a matrix form here. So instead of calling them as A2 B2 C2, let me call them as again the same format of x1 x2 x3 to get an iterative scheme. I will borrow the same control matrix of omega square by 3k. So omega square by 3k, I have the same control matrix of influence coefficient as this value, which is 444, 288, 147. I will multiply this matrix with this matrix and call this as x1 x2 x3, because the new x1 x2 x3 as we wrote here in the algorithm is now modified as a multiplier of this matrix on x1 x2 x3, that is what I am getting here. Okay. So instead of this I am substituting this here. Okay. So let us do that. 0 0 0 minus 1.58 minus 1 0 1 of this. So I simplify this, I get a control equation now which is going to be iterated to get omega and phi, which will be the second degree of freedom. So I should say here x1 x2 x3 of, this is actually the second mode, which is going to be omega square by 3k of this matrix of x1 x2 x3. So multiply these two matrices and get me this matrix, which is the control matrix now. Of course the first column of this matrix will be 0 because it is multiplied by a 0th column here. So 0 0 0 minus 4.32 1.68 1.68, second column 0 3, yeah, thank you. So minus 3 0 3. So I am looking for the second mode, I will have 1 0 crossing. Let me do that by assuming a vector which is 1 0 minus 1. Okay, it is a vector which will have only 1 0 crossing. Omega square by 3k of this matrix multiplied by 1 0 minus 1 will give me omega square by 3k of some vector with a multiplier. What is that multiplier? am I getting the multiplier as 3 and am I getting the same vector back? Do not copy, otherwise you will never understand this problem. You have to do it by simple calculation. You use the calculator and try to find out these answers. Is that okay? Yes. So I got back the same vector. So what can we say about this step? It is already converged. Okay. So let us pick up the first row of this. So 1, that is 1 0 minus 1 is equal to 3 times of omega square by 3k of 1 0 minus 1. So pick up the first row and equate to the first row. I should say 1 is equal to 3 omega square by 3k of 1, which will give me omega as simply root of k by m, which is my second frequency. I can call this as omega 2, and the corresponding mode shape is 1 0 minus 1. Any doubt here? So let us try to do the third mode. So again we will use the principle of orthogonality. I will have 3 modes here, A3, B3 and C3. The first mode, the second mode and third mode. So I want to write the orthogonality equations. I should say M1, A1 and A3, I am crossing 1 and 3 plus M2, B1 and B3 plus M3, C1 and C3 is 0 because I am crossing I and J. Similarly M1, A2 and A3 plus M2, B2 and B3 plus M3, C2 and C3 is again 0 because I am crossing 2 and 3, I and J are not equal. So M1 I have, M2 I have, M3 I have, A1's B1 C1, A2 B2 C2 now I have. Okay, A1 was, let us say A1 vector, the first mode was 1, 3.16 and 4 if I am right. The second vector was 1, 0 and minus 1, and the third vector I do not know, I call this as A3, B3, C3, and of course M1 is equal to 4m, M2 is equal to 2m and M3 is simply m from the problem. So substitute in this, develop 2 equations. Let us see how do we get them. I will remove this. So let us substitute back for M1, M2, M3, A1, B1s etc. get me 2 equations. So if I do that, it is going to be 4m of 1 of A3 plus 2m of 3.16 of B3 plus m of 4 of C3 is 0. That is the first equation. The second equation, 4m of 1 of A3, B3 term will not exist because this is cancelling, plus m of, okay, let us minus m of 1 of C3 is set to 0. So I got 2 equations, but still I have 3 unknowns. I can set one, let us say let C3 be indicated as C3 itself. This may be looking a very funny statement, but we have got to assign this to solve these 2 equations. So now what are A3s and B3s? A3 will become 0.25 C3, that is available in this equation straight. Substitute back in the first equation, B3 becomes minus 0.79 C3, is that okay? So I write a vector now, so A3 B3 C3, which I want to use for iteration, is now modified as 2 columns becoming 0, the last column will be 0.25 minus 0.79 and 1 of A3 B3 C3. Let us read it. A3 is equal to 0.25 of C3, B3 is equal to 0.79 minus of C3, and C3 is of course equal to C3, which I am getting the same equation. Now my control algorithm will be make use of this matrix of phi 2, this matrix of phi 2 which we already had with 1 column zeros, multiply this matrix with the new vector which I am going to call as x1 x2 x3 of phi 3. I am just rewriting it here, okay, I am rewriting it here itself. So I am making this as phi 3, this matrix already exists and this I am replacing with this matrix. Okay, so I am not writing it here, I am putting this matrix here with x1 x2 x3 of phi 3. Just for completion's sake, now I will get a new control matrix. I am saying x1 x2 x3 of phi 3, getting a new control matrix which will give me now do it sincerely, otherwise this will be very difficult. Do it sincerely. It is a simple matrix multiplication, you should be able to do it faster. So of course these 2 columns will become 0 because I have a multiplying matrix which is 0 and 2 columns. I am looking only for 3 values which are 0.41 minus 1.33 and 1.67. Is that okay? So now I am going to assume the vector says third mode, so I should have 2 zero crossing. So I can start from a positive to negative back to positive, I will get 2 crossings now, which will be omega square by 3k of this matrix of 1 minus 1 1, which will give me a multiplier of omega square by 3k of some value. Let us see what is this multiplier after iteration. So when you do with 1 minus 1 1, so I got a multiplier of 1.67 and this is 1, this is 2 phi I should say, and this is minus of 0.8 I can say. So, it is not converging. So, the next step 0.25 minus 0.81 omega square by 3 k, same matrix of same vector, I get a multiplier. So, this will now converge as with a multiplier of 1.67 out, 0.25 minus 0.8 and 1. So, equating the first row, removing it here, or equating the last row because there is unity there. So, I should say 0.25 minus 0.81 is equal to this multiplier of same vector getting repeated. So, it has converged. Looking at the last row, I can easily say 1 is equal to 1.67 of omega by 3 k of 1. This gives me omega as 1.34 root k by m, and the corresponding vector is 0.25 minus 0.8 and 1. Let us quickly see what are the observations or inferences we draw from this method, and what are the, let us say, merits and demerits or limitations or worries of this method. First, let us see the happy part of the method, then we will talk about the sad part of the method. So, this method has got many advantages and disadvantages. Let us see the happy part, then we will see the sad part later. The happy part is it gives me omega and phi, all of them. It gives me omega and phi in a corresponding pair. So, that is a great advantage. I do not have to search for it. For example, it is a jumble issue. I have got omegas given as 1.57 something 3 values and phi's as vectors. So, one does not know which belong to which omega. You need not have to check that. Okay, it gives in a pair. Gives in a pair. The method is easily programmable. I mean, how do we know the programming is a different part of it? We assume that we know the programming. So, easily programmable, I should say easily. Those who do not know this, then it shift to this next column also, but we understand it is easy, therefore it is easily programmable. Relatively, this method is faster, it is faster, there is no doubt. Most importantly, this method will give me omega and phi in a good sequence. First I got omega 1, I got omega 2 and omega 3, is it not? 0.45, 1 and 1.34. Look at the values, it gives me a good sequence. And more interestingly, people appreciate this method because this closely agrees with Dunkerley. Dunkerley's method closely tallies with this. I compared it, it was 0.4 and the first value is 0.45, not exactly cloning, but it is anyway agreeing. Though I do not have space to write the happy part, I have one more point here. It gives me orthogonal vectors. Eigenvectors are orthogonal because I made them orthogonal. Why we are making them orthogonal? To make the matrix multiplication simple, okay. That is the reason why we are making them orthogonal. The sad part are the following. So, the greatest sad part is how do you assume the vector? So, here I said 1 1 1 1 0 0 1 0 1 and so on. So, how do I assume it? The answer to the sad part is can assume accordingly 0 crossing, first crossing, second crossing, any number, still it will converge. It may take long number of iterations, but it will converge. The method will not diverge. That is the first worry. Second worry, of course, you have to unfortunately multiply at least 2 matrices at a given time. The matrix size is larger, then again we have worries, right, how to multiply them. And third part of course is the programmable component. The most important worry is the error what you commit is cumulative. That is a very big worry here. If you have done any mistake in the first, because this matrix has been derived from the first algorithm, it keeps on calculating and transferring it. So, that is a problem here. So, you have to be careful. Now, the question, once you know it is cumulative error, how to check? The checking process is check this with Dankali. That is how the method was developed. Okay. But this method will not check the eigenvector or the mode shape, it will check only the eigenvalue or the frequency. So, check this with the frequency and also physically see the first mode should be all positive values or all negative values, whatever may be. So, there should be no 0 crossing. I mean that physical understanding you must have. If you have these two physical understandings, this method can be easily handled. So, now do we have any questions related to these two methods? I will discuss 2 more methods in the next class, Stodla and Holzer, then matrix inverse, 5th method. So, all the 5 can be compared, and whoever writes a program for all the 5 and show to me for the first, he will get 10 marks directly added to your quiz. I will accept only one program. If the answer is wrong, 0, answer is right, accepted. I will give values from the audience. It should run for all the values. If the program runs for all the values and compares all the 5 methods, you will get 10 marks. If it does not work, no problem, you will get no marks, but unfortunately you will also not allowed to others getting marks. So, the best trick is give a wrong program immediately and block others opportunity. Okay, write a wrong rubbish program and see that nobody else is getting marks and you also do not get mark. That is how people generally do. Okay. So, any difficulties we have here, because I am going to give a quick exercise to you. Now, it is 9 minutes left over. We will give you a problem. Whoever does the influence coefficient matrix and the first eigenvalue and eigenvector, that is mode shape and frequency, first only one, we will give him 5 marks. I have the answers here. First right answer, whoever raises first his hand will be given mark if it is right, otherwise no. Other all will not get any mark at all. So, you can keep your hand now itself right. So, nobody else get any chance. So, it is 9 minutes, I will just write the problem if you have no doubt in understanding the method. If you have doubt, then the only thing is I have got to repeat the method once again in the next class. I am not tired of this, we can do it, but I think you can also try to do this yourself. It is a very easy algorithm. I am not going fast, my handwriting is excellent, so there is nothing like worrying about it, you should be able to follow it. We are not going faster, of course the method is faster, so there is a problem here. So, we will do this problem quickly. I am giving a very easy problem, let us see who is able to do this. I am giving exactly the similar problem like we do in nursery schools, right. I am just changing the numbers, that is all. Let us put them as k, k and k, m, m and m, x1, x2 and x3. Your time starts now. You have got about approximately 8 minutes. I want only omega 1 and phi 1. Those who are going to read the method now, you can raise your hand now itself, you will not be able to do it. Those who are very clever, try to raise your friend's hand. We will pick up the same problem in the next class, do it by some other method, then we will compare the answer. If the answer tallies, we will give the gentleman or the lady 5 marks. If it does not tally, whatever you have to give it to him or her, you can start doing it. So we will close it here.